Hey guys, if you know anybody who's supposed to be here and is missing, can you give them a shout out, either text message, Snapchat, or FaceTime or something? Tell them to get in here because we are going to be reviewing and it's good to be here for the review. So reach out to your friends, please. Okay, so what are we talking about? A hyperbola, an ellipse, a circle, a parabola, guys. We use completing the square to transform these to standard form. All right, so just like we did with the circle, what we do is we group the x terms, group the y terms, move the constant over. Now, in this one, unlike the circles we did in the past, okay, these though, there's a leading coefficient for the x squared and y squared term. So we're gonna have to factor them out. So we're gonna factor out the lead coefficient over here, factor out the lead coefficients over here. So we're gonna factor out a 9. That leaves us with x squared minus 2x. You wanna leave space for when you complete the square. Over here, we're gonna factor out the 4. That leaves us with y squared plus 4y. Leave space for when you do complete the square. And then 11 goes there. All right, so now we're gonna complete the square, guys, on the x term. So we take, all right, we're gonna take half of 2, which is 1. 1 squared is 1, okay? So we're going to add, let me use a different color here. We're gonna add 1 over here, because the 1 is inside the parentheses, which has a 9 leading coefficient. The number we're going to add to the 11 is actually going to be 9, because we have to take the 9, multiply it by the 1, and that's what we add to 11. Okay, now we're gonna do it on the y term as well. We take half of 4, which is 2. 2 squared is 4, so 4 goes inside the parentheses. And of course, what are we gonna add to the 11? Well, there's a leading coefficient of 4, so we're gonna do 4 times 4, which gives us 16, so we're gonna add 16 over here, okay? So now we're gonna factor that perfect square trinomial, which becomes x minus 1 squared. Same thing over here with the y's. Factor that perfect square trinomial, which becomes y plus 2 squared. And then we add all this up, so we get 36. Now, when we write these equations in standard form, they're supposed to equal to 1. So we got to get rid of the 36 here by dividing both sides by 36. So this simplifies to x minus 1 squared over 4 plus y plus 2 over 9. And this is squared, is equal to 1. So now it's in standard form. All right. So now that we have this in standard form, guys, let me ask you some questions about this particular equation. Hold on a second, let me erase this and I'll write some of them up here. All right, guys, so here are your questions. First, what is the center? Very similar to the circles, guys. What is the center of this ellipse? 1, comma, -2, the opposite of what's inside the parentheses. Which one is the major axis, guys?
Y.
Yep, the y. What's the radius of the major axis? 3. Take the square root of the 9. What's the radius of the minor axis? 2. Very good. What's the length of the major axis? 6. Good. What about the length of the minor? Length of the minor axis? 4. Very good. And then let's find the location of the vertices. Okay. Now, guys, be careful. Okay. We realize that the major axis is y. So this means that when we find the vertices, the y value of the center is going to change to accommodate the vertices. Now, how do we calculate where the vertices are going to be at? Well, we take the square root of the denominator. Okay, so the radius of the major axis is 3 units, guys. So in other words, it's 3 units from the y value of the center. So if we go 3 units from the y value, which is at -2, on the left side, we go left 3 units, guys, from -2. Where would the left vertex be at? -2 plus 3. You sure? On the left side. That's the right side, Sarah. Okay? You gave me the right side. Yes, the right side is going to be at 1. Because if the center is at 1, -2, to find the right vertex, we add 3. Okay? So that's going to give us a +1. To find the left vertex, we're going to subtract 3. So that's going to take us to -5. So that's the coordinate of the vertices, guys. Let me see. What does that say at the bottom? X minus 1 squared over 4 plus y plus 2 squared over 9 equals to 1 under the length. The length. Oh, that's the length of the minor axis. That's for the minor axis, okay? All right. Oh yeah, guys, let's find the foci. Now, remember the foci, they are on the major axis. No at the top, length of the major axis. Is that the one that's equal to 6, Presley? Which one? +3? You talking about this? Okay, Presley, you can annotate on my screen. All right. Okay, so anyways, guys, going back to what I was saying. The foci, they're located off the center on the major axis. How do we find them? We use the formula b squared equals to c squared, not c squared, a squared minus c squared. And a squared, of course, is the denominator of the major axis. B squared is the denominator of the minor axis. So in this one right here, the minor axis is 4, the major axis is the 9, and then we need to figure out what C is. So we subtract 9 from both sides, we get -5 is equal to -c squared. So c squared is equal to 5. Now, we're going to take the square root of both sides. So we get plus or minus the square root of 5. So, guys, be careful with this because remember, the foci, they're located off the center on the major axis. So since y is the major axis, this means that the -2 is going to be affected. So that 1 remains the same, but the -2, we're going to do plus or minus the radical 5 to it. And that would be where the foci for this ellipse are located. 1 comma -2 plus radical 5. The other one would be at 1 comma -2 minus radical 5. All right. Any questions, guys? Why is there a 3 there next to 5? Why is there a 3 next to 5? What are we talking about, Presley? Presley, right on the screen, go at the top where it says view options, and then use your pen or something to write on the screen. Guys, I'm missing a few people, so if you know someone who's supposed to be in here, like, who's missing here? I think Cassidy's missing.
Laura, I'm gonna
Yes.
contact.
Yeah, give her a call. You know, scream at her if you have to. Oh, that one? That's a +3, meaning 3 plus -2, sweetie pie, because you want to find the right vertex. The right vertex is 3 units away from -2. So in other words, you add 3 to the -2, all right? So that will get you to +1, which is this right there. All right, and then with the radical 5, that's radical 5. Is that what you're asking me? It's radical 5. And I'm putting the plus. What the heck? Okay. All right. So guys, Oh, the main question. So guys, where did the 9 come from? The 9. Oh, okay. So remember, this is a squared. A squared is the denominator of the major axis. The major axis was y. So the denominator of the y is 9. That's your a squared. Remember, when you look at these formulas, the formulas are x minus h squared over a, and then y, that's a plus, y minus k squared over b squared. These are all squared. So pretty much the 9 is already squared. So rather than having to take the square root and giving you 3 and then plugging it back and then squaring it, I'm just using the square. Same thing with the 4. That's the denominator of the major and the minor axis. It's already squared. So I'm just going to use that. Okay, so Presley, we calculated C. This represents C down here. So we took that in order to come up with the coordinates of the foci. Remember, the foci are on the major axis of the center. So we are adjusting the center coordinate, just the y value of the center, to accommodate the location of the foci. What's that for also? What? Okay. Okay, I see it. Never mind. Okay. Okay. All right. I thought it was just, okay. 1, -2 is the center. These points right here represent your foci. The foci are those 2 fixed points, okay, whose sum distance, okay, will represent all the points along that ellipse, okay? Whose sum distance from the foci will represent the ellipse. All right, guys, big question for you. When is it that an ellipse become a circle? What has to happen? Let's say looking at this equation down here. What has to happen to this equation for this to become a circle?
The denominator becomes like a 1 when you divide.
The denominator becomes 1. You're close. You're close. Okay. It's not 1 point, Presley. There's 2 points because we have a plus, we have a minus. That represents 2 points, Presley. I just wrote it as a compound answer. Axis has to be the same. Okay. Equidistant from center. When there is no major or no minor axis, that's good. The minor and the majors are the same number. Very good. Very good, Sarah, Gabby, and Paige. Very good. So essentially, when these 2 values down here are exactly the same, you will have a circle, guys, okay? So in other words, the radii is the same all around, okay? It doesn't change. So there's no major, there's no minor axis, it remains the same. So that's when an ellipse becomes a circle. All right, guys, so now here's a great question, and this question is going to appear on the final exam. Although when we do the review, we might be going over it again, but I want to go ahead and quickly go over this one. They want you to write the equation of an ellipse, and you are given that the vertices are located at -4, 6, 10, 6, and you have the focus at, notice I'm saying focus, not foci, 8, 6, because they're only giving you 1 in the problem. That's all they give you. And you have to come up with the equation of the ellipse. So the first question you have to ask yourself, is the center going to be at the origin? Is the center of this ellipse going to be at the origin, 0, 0, or is it going to be at h, k? Where is the center going to be at? H, k or 0, 0, guys? H, k. So you want to set up the format here, guys. of this ellipse. So it would be something like this. Now, I am not writing the denominators yet because we need to figure out which one of these is the major axis. Which one is going to be the major axis? Is it going to be the X or is it going to be the Y? What do you guys think?
X.
Now, how do you know it's X for sure?
The changing values of the vertices.
Right.
All the 6 stayed all the same.
Right. The 6's stayed all the same, but obviously the X's are changing. So this means that the major axis is going to be the X-axis, while the Y-axis is going to be the minor axis, okay? So guys, what do you think the Y value of the center is? Anybody? Okay, you guys are not quickly figuring. Okay, 6. Yes, that is correct because the 6 is not changing. It's the same for the vertices, the same for the foci, well, focus, because they only gave us 1, okay? So I am going to change this right there. Let's use a different color. I'm going to change that to 6. So now, guys, let's go ahead and find some additional information on here. Now, think about this. We have a horizontal ellipse, okay? It's going to be a horizontal ellipse. We're going to have 2 vertices. One of them is over here. The other one is over here. Now, the one on the left is located at -4, 6. The one on the right is located at 8, 6. Of course, the center is where you're
10, 6.
Huh? Go ahead.
10, 6.
10, 6. How do we find the center, the X value of the center, guys?
That's the focus. 8, 6 is the focus.
True, true. But right now I'm trying to find the center.
You put that as one of the vertices, is what she's trying to say.
Oh, very good. Thank you. Okay, Lee. Thank you. I didn't quite get what you were saying. Very good. Okay. We use the midpoint formula, absolutely. So we already have the Y value of the midpoint. We know it's 6. So now we need to find the X value of the midpoint. So the X value of the midpoint would be the average of the 2 X's. What's the average of the 2 X's, guys? -4 plus 10, and then we divide it by 2. So -4 plus 10 divided by 2 gives us 3, okay? So that's the the X value of the center. Okay, so I'm erasing all of that. That's the X value of the center. Are you guys okay with that? Yes? Okay. All right, guys. So I'm just going to go in here, change this, and make it a 3. Okay, so now let's work on the a squared and the b squared. Now, the major axis is the x-axis, guys. How long is the major axis? How long is it? What's the length of it? What's the length of it? Going from -4 to +10. How long is that? 14. Very good, Sarah. Okay, so now we know the length is 14. So we do half of 14 to get the radius of the major axis, which is 7. And then we're going to square it, and that's going to give us the denominator of the major axis. So this is going to be 49. All right, I'm pausing, guys. Any questions? No? Okay, what's your question, Presley? You got to ask your question, Presley. Okay, so you square it, and that gives you the a squared? Yes, absolutely. We take half of the length, which is 7. We square it, we get 49. Very good. Okay, so now, guys, let's address the focus. The focus is, look, ooh, Shazam. Let's undo that. Okay. The focus is located right about here at 8,6. All right. Now, how many unit is it to go from 3 to 8 over here, guys? 5 units, okay? So if we take the 5, we square it, that's going to give us our C squared for the focus. Remember, the focus is represented as C. All right. So now we're going to use that information to go ahead and figure out the B squared. So how do we figure out the B squared? Well, we go into the formula. Okay. And the formula is B squared is equal to A squared minus C squared. We don't have B squared. We have A squared, which is 49. We have C squared, which is 25. So B squared will equal to 24. So guys, that's the denominator for the minor axis. I'm writing the wrong thing here. All right, there we go. So that's one of the questions that's on the test. Guys, remember the entire test is multiple choice. All right. So next, I am going to move on. We're missing 3 people. Who else is missing? Okay. Where's Michelle? I'm not seeing Michelle in here. Michelle, are you here? I'm not seeing you. I'm going through my lips. I'm not seeing Michelle. Somebody reach out to Michelle, please. Are we going to review for the exam? Yes, Josh, we are. However, I got to talk a little bit about the hyperbolas, and then we'll go ahead and do that. Yes, absolutely. Okay, guys, so I'm going to transition over to the hyperbolas, which is in section 10.4. All right, so on the hyperbolas, I like to refer to them as super parabolas. Where did the 5 come from, Joey? To travel from 3 to 8, you have to travel 5 units. So that would be the distance from the center to where the foci is located. All right, guys. So now we're going to talk about the hyperbolas. Hyperbolas, as in 2 parabolas. So I call them the super parabolas, okay? Now, the hyperbolas, as you guys noticed from our little video, I hope you guys went back and watched that little video on the conic section. Looks something like this, okay, guys? So we can have vertical hyperbolas as well as horizontal hyperbolas. Okay, ooh, I didn't do a definition. So the hyperbolas, guys, they represent all points in the plane, unlike the ellipses, okay? The difference, okay, of whose distances from 2, oh, there goes those 2 fixed points. What do we call those 2 fixed points again? The foci, guys, is constant. Now, on this one right here, guys, you need to be very careful. The foci, they're located inside these little parabolas here, okay? So the distance from these 2 fixed points, whose difference will represent all the points on that hyperbola. So basically, the difference of the distance between these 2 points right there will represent all the points on the hyperbola. Now, for this one guy here, guys, this represents the center right there. Okay, there is a center. Now, right now, because we're on the XY plane, This is the origin right here. Let me go ahead and use a different color. This is the origin right here. This is one that's located at 0, 0. And just like with the ellipses and the parabolas, you can have the center at h comma k. But for now, just to expedite the process, I'm going to focus on the ones that have, okay, I may have to mention another one later on. I am going to focus solely on the ones that have a center at 0, 0. Okay, guys. Now next, the axis on which you have the hyperbola drawn is called the transverse axis. I know, what the heck is that? The transverse axis is the same thing as the major axis. And so the other axis is called the conjugate axis, or AKA the minor axis, okay? That's the minor axis. So once again, the axis where the hyperbola is drawn is called the transverse axis, all right? And that is also referenced as the major axis. So you will hear me say major because I want you guys to familiarize it with something else, okay? And of course, the conjugate axis is perpendicular to the transverse axis. In other words, the minor axis is perpendicular to the major axis, guys. Now, additionally, when you sketch the graph of these parabolas, they are ensconced between these two diagonal lines here. And these two diagonal lines here, guys, okay, that you are drawing the hyperbolas in between. Anybody care to guess what they are called? Because we've talked about them before. Anybody? What are they called, those two diagonal lines, dashed diagonal lines that the graphs of the hyperbola approaches, but will never get to? Yes, Joey. Yes, Gabby. Okay. Those are oblique asymptotes. Obviously, ooh, wrong ass. Hold on a second. There we go. Okay, oblique asymptotes. Now, guys, the oblique asymptotes, obviously the diagonal lines, they are sloped. So it's basically plus or minus rise over run. It's a slope line, okay? So whatever the change in the y is over the change in the x. So another way of writing this, be very careful, guys. It's plus or minus a over b, but because we like to refer to the major axis as a, the minor axis as b, make sure you reference this, guys. Reference this. You just have to make sure you have the rise, which represents your y, over the run, which represents your x value. And of course, you're going to have to take the square root of them. All right. So, what else do I need to tell you guys? Blah, blah, blah. Oh, the symmetry. These graphs, what kind of symmetry do you think these graphs have? What are they symmetric to, guys? Take a guess. What are they symmetric to? Think about symmetry. What does that mean? What are they symmetric to? They're symmetric with respect to the, come on, guys. They have multiple symmetries, I can tell you that.
To the x-axis.
The origin or the center, that's good. They are also symmetric with respect to the
X-axis.
the major axis, and one more. Major axis, transverse axis. What's the other one?
Minor axis.
The minor axis or the conjugate axis. So they are symmetric with respect to the transverse axis, aka the major axis, as well as the conjugate axis, aka the minor axis. Okay, guys. So now, the standard form of the equation of an ellipse may look like this: x squared over a squared minus y squared over b squared equals to 1, or it could be y squared over a squared minus x squared over b squared equals to 1. Now, the first one, there's a big or right there. The first one, X, is the major axis or the transverse axis. Now the second one, Y, is the major axis. So guys, here's the big question. I'm writing both of these down so I can ask you this question. How do you figure out which one is the major axis, which one is the minor axis? How do you figure out which one is the major axis?
By the denominator, which one's the bigger value?
No, that was for the ellipse. Whether X or Y comes first, you're getting there. You're getting there, but it's more than that. The direction of the hyperbolas, not quite. You guys are getting there. You're just not quite there yet, okay? So here it is, guys. Basically, you look at your X and Y. Which one is positive? That's it. Which one is positive? In this case, the X is the positive one. So it's the major axis. In this case, the Y is positive. It's the major axis. So in other words, we could have written the problem like this, okay? You would still have Y as the positive, not the bigger value. The bigger value that's subtract. No. Don't make it complicated, Wesley. Just look at the variable, whichever one is positive. That's the major axis, okay? So guys, you will notice when we talk about the circles in the ellipse, it's the sum of x squared, y squared. But when we talk about the hyperbola, it's the difference, remember back to the definition, it's the difference, okay, between the x squared and the y squared. I said that before. You said it's the positive one. What? Okay, I'm not quite sure. Okay, guys. So now, those equations here represented the ones with 0, 0 at the center. If it's got h comma k as the center, the only thing that's going to change is the fact that you're adjusting or you're transforming the x value, transforming the y value. So you're still going to have the difference right here, okay? Y minus k squared over b squared is equal to 1. It's still the same thing, the same process, guys. The only difference is x and y are going to be moved off, okay, transform, okay, off the center. So just be careful with this. Okay, all right. So anyways, guys, let's go ahead and look at some basic equations of the hyperbola. We're going to graph them together because the one on the test has to do with a graphing problem, okay? By the way, the foci, we use the same formula, guys, as the ellipses. B squared equals to c squared minus a squared. Same formula as before in order to figure out the foci. Now, guys, just be careful. Look at that. We have a difference right here. Be careful, okay, of c squared and a squared. Before, what was it? A squared minus c squared. So be careful, okay? All right, now let's go ahead and move on. We're gonna do some basic graphing, guys. Basic graphing. Let me see, let me find a good one here. Blah, blah, blah. Okay. We're gonna go through this very quickly. So make sure you guys are paying careful attention because I just want you to be able to get a basic one, okay? So guys, here's a basic one to get started. It is x squared over 25 minus y squared over 9 is equal to 1. So which one is the major axis, guys, or the transverse axis? Which one is the major? It's x. All right. Now, we need to find the asymptotes. Remember, think of the asymptote as, guys, rise over run. So it's going to be plus or minus a over b. The a has to do with the change in the y. The b has to do with the change in the x. And then, of course, because it's an oblique asymptote, it is a slope. So you make sure that x is there. Okay, so the a value in this case would be the 9, the square root of 9. So that would be 3. And the b value would be the square root of the x, the denominator of the x. So that would be 5. Are you guys okay with that for the oblique asymptotes? Any questions about that? It's rise over run. So the denominator of the y, whatever it is, whether it's the major or the minor, it doesn't matter. The denominator of the y, you take the square root of it over the denominator of the x, take the square root of it, guys. That's how you create those oblique asymptotes. You guys are good? All right. Now, the vertices, they're easy. By the way, guys, what's the center? I didn't even mention the center because, you know, we're talking about just the ones at the origin. The vertices are on the major axis of the center. Now, how do we find the corner of the vertex or vertices? We take the square root of the denominator of the major axis. So the vertices would be located at plus or minus 5, 0. So both equations for finding b are the same. In the first equation, it was b squared equals to a squared minus c squared IDK. I wrote it wrong. I have a, okay, hold on. Now, if you go back to the ellipses, Gabby, that formula that you just gave me right there, that is for the ellipse, okay? Now, when you go look at the one for the hyperbola, though, it's slightly different, okay? It's c squared minus a squared. Do you see that slight difference there? It looks like it's not much, but there is a difference. Okay, Gabby, in other words, this one is
I saw
actually,
Sarah.
hold on. This one is actually b squared plus a squared equals to c squared. Do you see that? Okay, go ahead, Lee, ask me.
For the asymptote, it doesn't matter which one's the major axis for when you find the asymptote, right?
Okay, when you're finding the asymptote, Lee, the way you think about it is this: slope. Slope represents a rise, a vertical change over a horizontal change. So at this point, it really doesn't matter which one it is, okay? Which one's the major, which one's the minor. You just gotta remember, it's the change in the y. So the denominator of the y, the square root of the denominator of the y over the square root of the denominator of the x. Rise over run, change in the y over the change in the x. Whether it's a vertical hyperbola, horizontal hyperbola, it's always the change in the y over the change in the x.
Okay, just making sure.
All right. Okay, guys. So, let me see. Let's go ahead and graph, guys. Let me erase some of this so we can graph it. Hold on a moment. I should have just cleared out the entire thing and just wrote the equation all over again. All right. So guys, there we go. Y equals to plus or minus 3 over 5. And then x are the asymptotes. The vertices are plus or minus 5, 0. So guys, here we go. We're going to go to the xy plane. And we're going to plot the asymptotes first, okay? Plot the asymptotes first. All right. So here comes my asymptotes. Remember, there's 2 of them. So now I'm going to go up 3 over 5. So that's going to take me right about, okay. There's my y-intercept. I am going up 3 over 5, which takes me to right about here. And remember, these are dashed lines, guys, okay? They're dashed because they're not a part of the graph. These are the guides that you use to help you graph them. All right, and I'm going to go down 3 over 5. 1, 2, 3, 4, 5, right about here. Okay, so now you've got your asymptotes. So the vertices are plus or minus 5, 0. So we do 1, 2, 3, 4, 5. And then we're going to sketch. Let me use a different color here. Okay, so we're going to sketch this part over here. By the way, this is called a branch. So we're sketching this branch over here. And then we're going to go to the left. 1, 2, 3, 4, 5. And sketch the other branch right there. And that's it. That's it. Let me see here. What else do I need to look at with you guys? Okay, I'm gonna look at the one that is on the test with you guys in a minute. Okay. All right, guys. Ask me a question. Wait, can you say the points again? Okay, this is the center. That's one of the vertices located at 5, 0. And then the other vertex is located right here at -5, 0. There you go. Okay, you good? All right, guys. So here's one of the ones you're going to see on the exam. And what I'm thinking is this, guys. Once I go over this here, I am not going to go over it when we go through the review, okay? Because I want to focus on the other ones we didn't do. For the oblique asymptote, okay, for the oblique asymptote, I am simply taking the square root of the denominator of y over the square root of the denominator of the x, because this is an oblique asymptote. It's a slanted line. It's a diagonal line, which means it is sloped. When you think about slope, think about it in terms of rise over run, or the change in the y over the change in the x's. So the y value, okay, its denominator, you take the square root of it, that represents the change in the y. For the x, you take the square root of the denominator of it, that would represent the change in the x's, okay? All right, guys, so here comes the next one, and maybe that will answer some of the questions you're having. So this next one right here is one of the questions on the test that has to do with a graph. I think this is the only graphing question on the test, guys. It is 25y squared is equal to 4x squared plus 100. So obviously this is not in standard form. You got to write it in standard form, meaning you want the equation to equal to 1. So the first thing we're going to do is subtract the 4x squared from both sides. So we are left with 25y squared minus 4x squared is equal to 100. To finish writing this in standard form, we divide every single term, both sides, by 100. So then this is going to simplify to y squared over 4 minus x squared over 25 is equal to 1. How did we get the center? Well, there's nothing adding to or subtracting from x and y, so therefore the center must be at the origin, so it's 0, 0. So like in the case of this one, Joey, the center would be at 0, 0, because there's nothing adding or subtracting from x and y. So the graph is not being shifted at all to the left and to the right. It just stays dead center. All right, so now guys, let's find the asymptotes for this one. What would be the equation of the asymptotes? Y, remember there's 2 of them, plus or minus what? Yes, 2 over 5. Okay, you want to take the square root of the denominator of y over the square root of the denominator of x. Go ahead, Lee.
Wouldn't it be a negative 100 because it's a positive 100 on the side?
What do you mean?
25 y squared minus 4x squared plus
No,
100.
equal 4x squared.
Oh, equal. Oh, sorry, I didn't say
Yeah,
that.
that's fine.
Plus.
All right, guys. So next question. What would be the coordinate of the vertices? Coordinates of the vertices. Come on, guys, you can do this. What you have to ask yourself is this a vertical parabola, as in y is the major axis, or is it a horizontal parabola, as in x is the major axis? Whichever one is the major axis, that means that when you write your vertices, that particular variable has to change to accommodate those vertices. And yes, y is the major axis, so then the center, the y coordinate of the center is going to change to accommodate the vertices. So it's going to be 0, comma, plus or minus 2. All right, guys. Do you want me to graph this one? Yeah, let's go ahead and graph it. Let's just graph it. Okay. So let me go ahead and erase part of this so we can graph it. And then, okay, now guys, I'm going to tell you, I am surface teaching this. I'm not going into depths with this information because we are essentially out of time. I'm just giving you just the basics. By the way, this particular chapter, for those of you moving on into trig, you're going to see this again in trig because they're going to apply the trig part of this to the conic section. So as long as you know the basics of these graphs, you'll be all right. Whatever you're missing, they'll go ahead and fill it in later on. So guys, here we go. We're first going to start out with the asymptotes, okay? We got 2 asymptotes. So for the first one, it's up to, we start off with the center at 0, 0. We go up to over, let me see here, 5 again. What? Okay. Shazam. And there we are. And then for the second one, we're going to go down to over 5. So guys, here we go. And so for this one right here, you guys are ready? The vertices are located at 0 plus or minus 2. So we got 1 along the y-axis at 0, 2. And then we're gonna draw, let me use a different color so I can draw these. Remember guys, the branches are inside those asymptotes. They get closer and closer to the asymptotes, but they will not touch the asymptotes, okay? And then the other one is down here at -2. So once again, they get closer and closer to the asymptotes. So we'll not touch it. Okay, there we go. Now guys, here's the big question. Why is this one wider than the other one? The previous one we drew. Why is this one wider? Anybody have a thought? There is a bigger change in X. Okay. Anybody else? Okay, so that's good, Gabby. That's good. Anybody else? Do you remember when we talked about vertical stretching and shrinking with the parabolas?
Is it because I think it's the absolute value of B or A is less than 1, it stretches, I think.
You're trying to remember the formulas, okay? So the smaller the value, the closer it is to the x-axis. The larger the value, okay, it's being stretched, so the closer it is to the y-axis. Do you guys remember that stuff? Sort of. Vertical stretching and shrinking, guys. Yes. All right. So I am going to have to stop here, guys, because like I said, I'm just surface teaching this. It's already 10:10, and I want to spend some good quality time on the review. I am going to simply go through the review that I posted on my math lab for you guys and go over some of these questions. I am not going to do every single problem on there, okay? I am only going to go over the ones which I feel you guys will need help with. And your exam, guys, is this Friday. Once again, it is going to be administered on here on, let me see here. There it is. Okay, it's going to be administered on Zoom because I have to observe you doing the exam, okay? And then, of course, people, you have to turn on your camera so I can see you. So if you currently are at a computer where your camera doesn't work, then you might want to consider finding a camera that works, or maybe you can turn on Zoom on your cell phone so you can have the camera on, and then you go to Blackboard on your computer so you can access the tasks. All right? But I need to observe you taking this exam, all right? So 90 minutes is all you have for those 25 questions. I don't think it's going to take you guys 90 minutes, but we'll plan on the 90 minutes. All right, let me see.
Get a score after we submit it.
Say it again. Yes, you will
Do we
get
get
the
a
score immediately. Yep. And then one more time, for those of you who need to, hold on a second, who need to substitute your exam score for the lowest test score, after you're done, I will do it for you immediately. Once we finish, yes, you can leave once you finish. And that's it, guys. Once you finish, I'm done with you. If you want to chat with me, you can chat with me. By the way, no talking to people during the exam, because I can see you speaking to people. I had to reprimand some people on Monday night because they were sitting there just talking away to people like they're having a good old time. This is an exam, people, okay? And then I do not speak to you while you're in the exam. I chat with you, so you have to make sure you keep an eye on Zoom just to see if I'm not sending you any messages, okay? All right, guys. So now we're gonna start on the review. I am going through the DNC that I populated for you on my math lab. So here it comes. The first question is on inequality, okay? We're solving a rational inequality. And when you're solving these rational inequalities, the first thing you got to do is find those restrictions, the restricted values. Okay, 7 1/3. Let me switch this over just in case you guys have questions. Now, okay, so guys, we have our restricted values. Now we're going to solve this. The appropriate way to solve this is to actually move everything, isolate everything to the right, and then solve the problem. But just to expedite the process, we can do this. 7 over x minus 7 is equal to 8 over 3x minus 1. And this works. So we cross multiply 7 times 3x minus 1 is equal to 8 times x minus 7. And then we're going to go ahead and solve this out. 56. I'm going to subtract 8x on both sides. Now, some of you may be saying, well, can I do this on my calculator? You can, but the problem is picking up values like 1/3, guys. That's going to be really difficult to pick up those values there, okay? I'm left with 13x minus 7 is equal to negative 56. I add the 7 to both sides. So that's going to give me 13x is equal to, ooh, nice, a negative 49, which is going to give us a fraction in the form of x equals to negative 49 over 13. Anybody want me to show how to do it the other way around? Anybody? You sure? Because there's another way to do this, guys. As in, move both fractions to the other side. You know what? Let me quickly do that. I don't want somebody coming back to me and saying, well, Ms. Foster, that is not the way the textbook did it, and that is not the way my math lab did it. Okay, so let me show you quickly. So what you do is you rewrite the problem so you can isolate the rational expression on one side, okay? Now, obviously, we have to find the least common denominator. So you would have to go ahead and take the 7 multiplied by 3x minus 1, take the 8 multiplied by x minus 7, and you want to keep this over x minus 7 times 3x minus 1. I know what you guys are saying, but wait a minute, this is so complicated. And so once you have it in this format right here to solve the problem, guys, all you have to do is take the numerator and set it equal to 0. Look at that. Takes you right back to where you were. Okay, 8x minus 7 is equal to 0. 21x. Okay, minus 7 minus 8x plus 56 equals to 0. So 13x plus 49 is equal to 0. Look at that, 13x is equal to negative 49. You get the same thing, okay? Same thing. All right, guys. So we're not done yet. The answer, okay, will have to be, I'm not sure, I didn't see how they wrote out the options, but you may have to graph it and write the interval in the solution in interval notation. You definitely have to write the answer in interval notation. So let's go ahead and do that part, guys. Just remember those answers, guys, because I'm just going to clear this out. It makes it so much easier to just clear out the entire thing. Okay, so I have 3 values, negative 49 over 13. There was another value at 1/3, right, guys? 1/3, and then the other one is at 7. So now I am going to test out, oh shoot, I need this. What's the denominator? X minus 7 greater than, okay guys, help me out here. What's
8 over 3x minus 1.
8 over 3x minus 1. Okay. So of course the best number to test with is 0. Once you divide up the number line into these regions right here. Okay, we're dividing it up into those regions. Okay, there we go. Oh, Shazam. Come on now, work with me. Okay, this thing's not working with me. So let's keep going. So let's test with the 0, guys. We're gonna take 0, plug it in for each x. Plug it in to the original problem. See what it does to the problem, okay? So here, we're gonna get 7 divided by negative 7, that's negative 1. 8 divided by negative 1 is negative 8. Is negative 1 greater than negative 8, guys? Yes, no, is negative 1 greater than negative 8? Yes. So this region right here is true. Since the truth values are alternating most of the time, that means this region right here is false. If you're not sure, plug in a value. This region would be true, and this region right here would be false, okay? Since they're alternating most of the time. Now, of course, if you're not sure, test out something else. Like I am going to test out the 1. If I test out 1, let me see. Oh shoot, I just erased this thing again. Okay, I'm just gonna stop here. Okay, so guys, we have a set of solution in between the negative 49 and the 13. Now, the one thing I do need to say is this, guys, be careful, because if you have an inequality where, okay, right here, they're both going to be parentheses. We're not going to include the endpoints. Now, listen, if you have an inequality where it's greater or equal to, less than or equal to, those restricted values, you cannot use brackets with them. You would have to use parentheses with them. So in other words, on the 7, you would have to use parentheses. On the 1/3, you would also have to use parentheses. So be careful with that. This one was not equal to, so that's why I did not mention it, but I'm mentioning it just in case you see that on the test, okay? So then another set of solution will be from 7 all the way up to positive infinity. So if they needed you to graph it, this is what the graph would look like. But then when they want you to write this in interval notation, it will be parentheses, negative 49 over 13, comma, 1/3, and then union from 7 up to positive infinity. And there you are. All right. Next one. Number 2. Let's see what number 2 says. Okay, number 2. Ooh, this one's very similar to the previous one. You guys tell me if you want me to do this one. This one is very straightforward, unlike the previous one. You know, move the 12 over, factor it, plot those critical values on the number line, and then test each region. Are you guys going to be okay with this one right here? Because I don't want to spend too much time on a problem that you're all right with. Okay, it's just like the previous one, guys. Factor it, and then find those critical values, and set the critical values on the number line, plot them on the number line, and test each region. -6, +2, test each region, okay? And then write your interval solution. And when you're writing the interval, because it's greater or equal to, you're going to use brackets when you write your interval notation. So I am not going to finish this one. You'll be fine with it. All right. I'd rather spend more time on the ones that you may have a difficult time with. All right. This next one right here, guys, number 3, they're giving us f of x is equal to 4x cubed minus 13x squared plus 2x plus 8. And the question is this: use the remainder theorem to find the remainder when f of x is divided by x minus 3. Then use the factor theorem to determine whether x minus 3 is a factor of f of x. Very straightforward, guys. All you have to do is figure out the value. What value would we use if we're going to divide this polynomial right here by x minus 3? What value would we use for the divisor? Ooh. Okay, I have to be on the other screen. Hold on a second. Yeah, we would use 3. So since 3 is the value that we would use, if we were to go ahead and find the value of this function at x equals to 3, that would lead us directly to the remainder. Now, how do we know if x minus 3 is a factor of this polynomial? What would have to happen? Oh, that's given, Wesley. That's given. Okay. What would have to happen in the remainder? Very good, Gabby. It has to equal to 0. All right. So, guys, we're going to plug it in for every single x and then work it out. So you just grab your calculator and really, you just plug it into the calculator and let the calculator work it out for you. So that's 4 times 27. Somebody plug this into the calculator, please. 13 times 9 plus 8 plus 8. Let me see. That's 108 minus. Okay, somebody plug this into the calculator, please. Okay.
Why'd you put 2 8s? Wouldn't it be a 6 because 2 times 3 is 6?
Yes, I got sidetracked there. Okay. 13 times 9 is going to be 117. And then plus 14, 108 minus 17 is a negative 9. Negative 9 plus 14 is going to give you 5. Did you guys get 5? Oh, thank you, Gabby. Okay. So, guys, is the x minus 3 a factor of the polynomial? Nope. Why is it not a factor? Because the remainder is not 0. That's why. Okay, next one. Number 4. For this particular problem, oh, it's a synthetic division problem. Are you guys going to be okay with this one? We have to divide it synthetically. We got division problems coming up. I think you guys should be okay with this one. Anybody want me to work it out? I just need one yes if you want me to work it out. Okay, Presley. All right, guys. So this is actual synthetic division. So what's the value of the divisor? What number plus 4 makes the denominator 0? Negative 4. And so we want the coefficients. We want to write down the coefficients of every single term of the polynomial. X to the 5th has a coefficient of 1. X to the 4th is missing. We fill in a 0. X to the 3rd has a coefficient of negative 2. X squared is missing, so we fill in a 0. The coefficient of x is 2, and the constant term is missing, so I fill in a 0 to hold place values. Drop the 1. Multiply 1 times negative 4, that gives you negative 4. Add, so you get negative 4. Multiply this negative 4 by this negative 4, so you get positive 16. You add, you get 14. 14 times negative 4, that's going to be a negative 56. You add, you get negative 56. Negative 56 times negative 4, that's going to be 224. And you add, you get 226. And then 226 times 4, that's going to be 904. Somebody check me on that. Oh my God, I'm trying to squeeze 904 here, guys. Okay, it's here. 904. She's in here. There we go. Oh, it's going to be a negative. It's going to be a negative. So now we're going to go back in and fill in the variables. So we're going to start off with x to the 4th, followed by x cubed, then x squared, and x. So the quotient is going to be x to the 4th minus 4x cubed plus 14x squared minus 56x plus 226. And of course, the remainder goes over the divisor of x plus 4. And guys, once again, the test is multiple choice. All right. Next one. By the way, this exam right here, I think because it's on the computer, they've made it harder than it normally would be. Because the previous ones that I've seen, guys, they've been so easy. I've been shocked, okay, how easy they were. But this time, this is a bit challenging. So take your time with these problems. Okay, so they're giving you this polynomial right here. And they're giving you a 0, okay? And the 0 is 4i. And they want you to find the remaining zeros. Find the remaining zeros. Now, remember, the rule states that when you're dealing with imaginary values or complex values, as well as irrational values, they always travel in pairs. So if you have a positive 4i, automatically you have its conjugate, negative 4i. So they're giving you actually 2 zeros. This is a third degree polynomial. So the polynomial is actually in the form of x minus 4i, that's the 0 they gave you, x plus 4i, that's the conjugate, and then you're missing 1 0. So your job is to find that one missing 0. Now we're going to multiply these two together. When we multiply them together, I'm just going to go ahead, because they're conjugate, multiply the first two terms, multiply the last two terms. So I get minus 16i squared, and I squared, of course, is negative 1. So that's going to give me x squared plus 16. And all of this will be multiplied by x minus c. So the question you're asking yourself is, what should this binomial be? So when I multiply it by this one, I get back to the original polynomial. Guess what we're going to have to do, people? What are we going to have to do to figure out this other binomial? Anybody? Ew. We're going to have to do division. And not just any division. We're going to have to do long division. Okay, so let's do it. Let me erase some of this so I could do my long division. Okay. So here comes the long division. We're going to take the x squared plus 16 and divide it into the polynomial so we could get the quotient. And the quotient will be the other factor, which will lead to the other 0. I can't do long division. Come on, Sugar Plum, come on. Okay. X squared plus 4. No, 16. We're going to divide it into the polynomial x cubed minus 7x squared plus 6x minus 112. All right, so we're going to take the x cubed divided by x squared. That's going to give us x. X times x squared is x cubed. That's expected. X times 16 is going to give us 16x. Now we're going to subtract. So these two cancel out. Bring down the negative 7x squared. 6x minus 16x leaves us with a negative 10x. And let me see here. Let me erase this part right there. Okay, so we're going to do it again. This time we're going to take the negative 7x. And we are going to take this negative 7x squared and divide it by x squared. What's negative 7x squared divided by x squared? That's going to give us a negative 7. Now we multiply. Negative 7 times x squared is negative 7x squared. That was expected. I guess I should have brought down that negative 112. Shazam. Okay, now negative 7 times 16, that's going to be 112. Somebody check me on that, please. Negative 7 times, yeah, okay, very good. So now, guys, we're going to subtract. Look at what happens. This cancels out. This cancels out, leaving you with a negative 10x. I'm not supposed to have something left over here. What did I leave out? Okay, it's supposed to zero out, guys. I think I left something out. Oh, Shazam, Shazimi. Oh my goodness. Guys, this should have been, ooh, let me go ahead and write it in a different color. Shazam. I wrote the wrong color. Okay, so this should have been 16 right there. So that's 16. So essentially, this cancels out with that one. Okay, so we didn't even have to worry about this there. So bottom line, this all cancels out to 0. Now, guys, let me make a point here. Since I made this huge blunder, you notice how I said, wait a minute, something's wrong. I expected this to come out to 0. Because if x squared plus 16 is a factor of the polynomial, when I do the division, guys, there shouldn't be a remainder. There should be a remainder of 0, as in everything should cancel out, okay? That's how I knew I made that blunder, okay? That's what happens when you know the basics of what's happening with these problems, guys, okay? You checked yourself. So I just checked myself, Shazam. All right, so guys, here's my remainder. My remainder is x minus 7, which is a factor of the polynomial. Therefore, it's going to lead me to the other 0 of the polynomial, which is 7. So what is the outcome of this polynomial? What are the zeros of this polynomial? Plus or minus 4i, comma 7. And there's your zeros. Now, could you guys have used your calculator for this? Of course, I haven't mentioned the calculators that much. Yes, you could definitely type in the original polynomial into your graphing calculators. Okay, since they gave you the imaginary solutions, all you really had to do was find the real solution. This was the 3rd degree polynomial. They gave you 2 imaginary solutions. So all you're missing is that one real 0. Okay, so next one, guys. This is a composite function. And this one is problem number 6. They are giving us, now why is that stuck up here? Okay, there we go. That was bugging me. They are giving you f of x is equal to x minus 10 over 6. G of x is equal to 6x plus 10. Now we got to find g of f of x. So g of f of x says, take the f function, plug it into the g function. So we're going to take f, plug it into g. So we're going to take this, plug it in here for x, guys. So g of f of x will equal to 6 times x minus 10 over 6. That's the substitution. And then plus 10. Shazam, what happened with this one right here? Interesting. Just because mine is turning out this way, guys, doesn't mean that yours is going to turn out to be this way. Ew, but I have a great question, people. Since f of g of x, g of f of x is equal to x, okay, without doing the f of g of x, and I think it's going to turn out to be the same thing too, what can we say about these two functions, f of x and g of x?
Inverses of each other?
Yes, very good, Lee. They're inverses of each other. Excellent. All right, guys, next one, number 7, we got a word problem. I didn't see too many word problems on this, so you guys don't have to worry too much. And this one just happens to be one of those exponential functions. B is equal to 4,400 times e to the 0.03t. It says the number of books in a small library increases according to the function b. Talking about books. Oh, my Lord. I love it when things are in synchronicity. Where t is measured in years, how many books, hold on a second, let me move this, it's covering it. How many books will the library have after 6? Oh, guys, this is easy. They just want you to find b of 6. So I'm not doing this one. You guys do it. Just plug it into your calculator. Ooh, that's easy. Plug that into your calculator. Ooh, now let's do this log equation. Number 8. 7
What's the
plus,
original one? Is it 4400 or 400? Because you wrote it different both times.
4,400.
Okay.
I was trying to get out of the problem. Ooh, Shazam. Okay, there we go. 7 plus 4 times natural log of x equals to 12. We're going to isolate the log term. So this cancels out, leaving us with 4 natural log x is equal to 5, 12 minus 7. And then we're going to divide both sides by 4, guys. So we're left with natural log x is equal to 5 over 4. We're going to convert this to an exponential equation. What's the base of the natural log?
E.
E, yes.
Right.
So this would become x equals to e to the 5 over 4, guys. That's the exponential equation. And that's it. You guys are good? I can't believe this class is almost over with. Here comes another log equation, guys. Oh, it's not an equation. It's actually an expression, and they want you to condense it into a single log base. All right, so this goes back to the properties of logs. Subtraction becomes
Division.
Division. Addition becomes
Multiplication.
multiplication. There's a catch over here, guys. There's a catch. Here's the catch. You see that +2? There's nothing after it. It doesn't have a log base. So put your thinking caps on, guys. What should we need a log base with the 2. What should the log base be for 2 so we don't change the 2? So it remains 2. So what log base should we multiply it by? So it still remains 2. Come on, guys.
Two log. It's an exponent.
No. In other words, what should we multiply a number by so that it remains the same?
1.
1. So what log base is going to give us 1? True, Sarah, but what's the base on this log, Sarah?
A.
Yeah.
Wait, a to the 1. That makes like log base of a to the power of 1, 2.
You're almost there, Lee. Almost there. Okay. So, guys, we want to write a log base that will be equivalent to 1. And the log base must be log base A to match the other ones. You want all of them to have the same log base. So it's going to be log, I should use a different color here. Log base A of A. What's log base A of A simplified to? Just 1. So guys, we still have 2, except now we've added this 1 value here that's not going to change the 2, so we can condense the log. Okay, now this coefficient is going to become a power. This coefficient will also become a power. This is also a coefficient. It will become a power. So when we express this in condensed form as a single log base A, it's going to be log base A of 2x plus 1 to the 3rd over 2x minus 1 to the 2nd. And then all of this is being multiplied by a squared. Now, you can also rewrite this as log base A of a squared times 2x plus 1 to the 3rd. Oops, Shazam. Okay, to the 3rd over, do we really need the parentheses there? We really don't need the parentheses right there like that. But it's okay, guys, if you want to leave them there. Another way is to go ahead and do this. Okay. This might actually be a bit cleaner. Okay, just rewrite it like that. Oops, let's go back. Okay, now where's the parentheses? Okay, there it is, like that. Okay, So be careful, guys. Remember, it's multiple choice. Oh my God, it's another log equation, guys. It's another one. Okay. Oh, this one's easy. Log 5x is equal to log 6 plus log x minus 3, everyone. Okay, so we just finished talking about condensing the log. On the right side of this one, we're going to also condense the log. So this will become, let me see here, that's an x, log 6 times x minus 3. Now, because we have the same log base on both sides, we can use the 1-to-1 property of logs. That says if the log bases are equivalent, that means the arguments are equal to each other. So we take the 5x, set it equal to 6 times x minus 3, and solve it. So 5x will equal to 6x minus 18. So what would x equal to for this one, guys? X would equal to what? Come on, everybody. 18. Very good, Sarah. Very good, Gabby. All right, there we go. That's awesome. Okay, guys, remember, we're meeting right here on Friday, same time, same back channel. And then you got to turn on, once you come in, I will have the password on the screen. And then, oh, Shazam, I forgot. You guys have to submit your work. You got to take pictures of them and send your work to me, okay? And your work has to add up to your answers. If they don't add up, I'm supposed to deduct points from you, okay? All right, guys.
How do we send you pictures of our work?
Just take a picture and text, email it to me.
So do you want it to go through Teams or like email you? Which one would you prefer?
College, irc.edu. I mean, you know my email address.
I think.
Okay. Well, actually, no, we don't need to do this one, guys. This one, they just want you to write the augmented matrix. That's easy, right? The augmented matrix, just take out the values and write them down. You guys are okay with that, right? Okay, let's move on. Oh, talking about augmented matrix. Now, they're giving you negative 2x plus 5y minus z equals to 5. And this one right here is number 12. Okay, I need to say something about this one, guys. They want us to solve it. They want us to solve it using row echelon form.
Oh, man.
No.
I just take forever to do. You're not doing
the reduced row echelon. You're just doing row echelon.
But do you know how many pages of work that is?
A waste of paper.
I love it when you get excited like that, Lee. You don't have to. You didn't let me finish, Lee. Okay. So guys, listen. You do not have to use row echelon, row operations to solve this, okay? You can just go ahead and use the method you're comfortable with. It's a multiple choice test. Hello? So
Yeah.
you want to use Kramer's? We'll use the determinants.
Maybe.
Do you want to use elimination? It's up to you. Okay? So you don't have to use row operations because it's a multiple choice question. Okay?
But don't you need to send you the work? Or does it matter?
Yep, I want you to send me your work. So if you are going to do row operation, of course, the first thing you would have to do is write your augmented matrix, coefficients of x, coefficients of y, 5, -8, 1, coefficients of z, -1, -2, +1, and then the constant terms of 5, -32, and -5. And then you go to work if you're going to do row operations, but you don't have to do row operations. If you are going to do row operations, the first thing I would do is swap row 2 with row 1, because remember, in order for you to arrive at row echelon form, the main diagonal, guys, must consist of all ones. All the values, all the elements below the main diagonal must be zeros. And then once you accomplish that, then you've essentially finished with row echelon form, and then you back substitute to figure out the remaining values of variables. But you don't have to do it this way. You could use elimination. You could go
So
ahead
when we
and
send you the work, it doesn't matter what the question asks for, we can do in our own way.
Yep. All righty, guys. Number 13, they want us to find the product of two matrices, -2, 3, 4, comma 2 times -2, -1, comma 0, and 4. You got to find the products. Now, this is one you can actually do on your calculator.
Yeah, I tried that. That was pretty good.
And we only get 90 minutes. Yep, Gabby, we get 90 minutes. Do we have to do it that way? Okay, we got that already. All right. By the way, guys, there is a timer on the test that will keep track of how much time you have, so keep an eye on it. Do I need to do this multiplication, guys? Yes, no? Okay, this one's easy because they're both 2 by 2. So you know the resulting matrix is going to be a 2 by 2 matrix, okay? So your resulting matrix will also be a 2 by 2. So the element that goes in row 1, column 1, you're going to take this row right here, okay, multiplied by this column right there. So we're going to do -2 times -2 plus 3 times -1. Work it out. You get 4 minus 3, which gives you 1. All right. So to get row 1, column 2, the element that goes right there, here, let me use my little pointer, the one that goes right there, row 1, column 2, we're going to take, let me use a different color here, okay? We're going to take the same row again. This time we're going to multiply it by this column right there. Well, obviously, row 1, column 2 will be -2 times 0 plus 3 times 4, which is actually 12. So 12 goes here. Now we're going to go to row 2, column 1. So we're going to take this row right here, multiply it by this column. So we're going to get 4 times -2 plus 2 times -1. So that's going to be a -8 minus 2, which is a -10 with this element right here, -10. That's a 10 there, guys, okay? And then last but not least, row 2, column 2. We're going to do row 2 multiplied by column 2. So 4 times 0 plus 2 times 4, and that's going to give you 8. And there you are. All right, guys. I hope you guys remember how to do this one. We got to find the inverse of this matrix. The inverse. Now, okay, I showed you the way the textbook shows how to do this, and then I gave you that shortcut too, which reminds me, there was a shortcut for the determinants, but I forgot to do it, so I'll mention it here quickly to you guys. So the way to do this, okay, is to actually use row echelon form. Yeah, this is the identity matrix here, guys. So your job is to use row echelon form so that you end up with the identity matrix on the left, and then the matrix you end up with on the right over here will become the inverse. The inverse of the matrix. However, there's a shortcut. What is the shortcut? If you have a matrix in the form of A, B, C, D, and they want you to find the inverse, let's say this is matrix A, and they want you to find the inverse of it, the inverse would be 1 over the determinant of A times D, negative B, negative C, and A. I think that's a quicker way to get to the answer, guys. So in the case of our little matrix here, the determinant of A will equal to 6 times 3 minus 0 times 5, which is 18, okay? And then, guys, remember this is our A value right there. That's our B value. That's our C value. And this is our D value right there. We're going to plug them into the formula accordingly. So for us to get the answer for this one, we're going to do 1 over 18 multiply by 3. The 6 goes here. Okay, 0 stays here, but the 5 becomes a negative. And then you want to multiply 1 over 18 times 3 is going to give you 1/6. 1 over 18 times negative 5 is going to give you negative 5 over 18. And of course, this is going to be 0. And 1 over 18 times 6 is going to give you 1/3. There's the inverse. Ooh, be careful, guys. Be very careful. Questions? All right, let me see, because I'm not going back and forth. Can we use our calculator to get the inverse? Yes, but Presley, you got to show me some work. You can use it to verify it. How about that? Yes, guys, it works on the calculator. Hopefully you were here for that section when we did it on the calculator. So now we're going to go to a partial fraction decomposition. Shazam, guys, it's almost 11 o'clock. Okay. So, listen, if you need to leave, you can leave. I'm going to continue for those of you who want to continue with the review, okay? If you need to leave, you can leave, okay? Because I've kept you for a very long time. And yes, the review is on there, guys. What? I'm sorry. I'm sorry. Let me see. Determinant of A, Presley, okay? Determinant of A. Okay, guys, here comes the partial fraction decomposition. It is 7x squared minus 7x plus 4 all over x minus 1 cubed. All right. So guys, here we go. On this one right here, we are going to set up our partial fraction decomposition. And remember, because the factors in the denominator, they are linear. Oh, that was you, Josh? Okay. Yes, Joey, it's going to be a 2 by 2 on the test. We're going to have a over x minus 1 because it's a repeated factor. The second fraction would be b over x minus 1 squared. The third factor would be c over x minus 1 cube. Okay, so now time to go ahead and simplify. Remember the fraction on the left is just going to be the numerator you're going to have left with, okay? Now, the LCD, guys, I didn't mention the LCD, but let me mention the LCD. Obviously, the LCD will be x minus 1 multiplied by itself 3 times. So that means the left side simplifies out, so that leaves you with the numerator. Now, when you go on the right side, if you take x minus 1 cubed, multiply it by a over x minus 1, you'll be left with a times x minus 1 squared. And if you go to the B1, you multiply it, you'll be left with x minus 1. And then if you do it with third fraction, you'll be left with C. So let's go ahead and work it out, guys. That x minus 1 squared, when you expand it, it's going to become a times x squared minus 2x plus 1. Distribute the b, so you get bx minus b, and then plus c. All right, so 7x squared minus 7x plus 4 will equal to ax squared minus 2ax plus a plus bx minus b plus c. So now, guys, time to go ahead and equate the left side with the right side. So here we go, guys. This is ax squared. This is 7x squared. So that means a will equal to 7. Now we have an x term here and another x term here. You want to factor out the x's. And when we factor out the x's, we're left with negative 2a plus b times x. So this means that negative 2a plus b will equal to the coefficient of x, which is negative 7. That's the second equation. And then last but not least, guys, let me use a different color here so I can make this point. We have an a minus b and a c plus c. All of that will equal to the constant term. So that's going to be a minus b plus c is equal to 4. So now we have our system. So we're going to solve it, guys. Okay, so let's go ahead and solve it out. I'm going to erase some of this out so we can solve it out. By the way, guys, we already have the value of a. To be honest with you, this is an easy problem. If we already have the value of a, and we know negative 2a plus b is equal to 7, and a is already equal to 7, we would take that a value, plug it in, and work it out. So negative 14 plus b equals to 7. So it looks like b is going to be 21. And then for the a minus b plus c, a is 7, b is negative 21. So you're going to have 7 minus 21 plus c is equal to 4. 7 minus 21 is 14. Negative 14 plus c equals to 4. Add the 14 to both sides. So you get c is equal to 18.
But Miss Del Sierra, it's negative 2a plus b equals negative 7, not positive 7.
Why'd you wait until now, Paige, to say that? Man.
I didn't want to interrupt.
You should have. Okay. Okay, I left out negative. I'm backtracking. All right. So guys, that's a negative right there. That's another negative right there. So this is actually going to, what? A positive 7. Okay. Well, that makes it even easier, people. If A is 7 and B is 7, guess what C is going to be?
4.
4. What now? Wait a minute now. Oh, okay. So let's write out the partial fractions. Wow, isn't this an interesting outcome? So guys, the partial fractions will be 7 over x minus 1 plus 7 over x minus 1 squared plus 4 over x minus 1 cubed. Shazam. Very interesting. Guys, if you need to leave, you can leave. The next one requires you to find the determinant. Now, between all this hoopla about the coronavirus and our extended vacation, I don't remember if we talked about this alternate way for us to find the determinant, guys. They want us to find the determinant. of a 3 by 3. Now, yeah, the determinant of a 3 by 3. We did that.
Yeah.
But when we did it by minors. And there's an alternate way to do this, guys. Here's the alternate way to do it. Some of you may like it better, okay? Because I forgot to mention that to you guys. So what you do, follow along with me. It's not that difficult. What you do is you take the first row. You rewrite it over here. 3, 1, 1. You take the second row. Rewrite it over here. And you're going to do 4, -4, +2. Now, go along with me here, guys. We're going to do the main diagonal here, the diagonal here, the diagonal here. We're going to multiply them together, okay? So multiply all these numbers that I've crossed out together. So for the first one, I'm doing 3 times -4 times 4 plus 4 times 2 times 1 plus -3 times 1 times 2. Okay, we're not done yet. Now, then I am going to subtract, okay, subtract, okay. So I did the diagonals along the main diagonal in a downward process, and now I'm gonna go upwards. So this is the main diagonal right there, that's 1. Then I am going to do, oh Shazam, this is not lining up very well. This one and this one, just like we did with the other one, we're going to multiply them, but we're gonna have to subtract, okay? So we do 1 times -4 times -3 plus 2 times 2 times 3 plus 4 times 1 times 4, guys. This is another way for you to go ahead and find the determinant of a 3 by 3 matrix, which I think I may have, did I tell you guys about this before?
No.
Okay, because I forgot. Because I think we're in the middle of working on these and then we went off on our extended break. I don't remember, but whatever. So guys, let's look. We multiply here. 3 times 4 is 12. 12 times 4 is 48, so that's -48. 4 times 2 is 8. -3 times 1 is 2. I mean, -3 times 1 times 2 is -6. So that's going to give us a -46. Okay, now we're going to do this one over here. Do that. Okay, so it's going to be 1 times -4 times -3, which is 12. And then, remember, this is subtraction here we're doing, okay? 2 times 2 times 3. Guys, if you got a calculator, put it on the calculator to see if this adds up. 4 times 3 is 12. 4 times 1 times 4, it gives you 16. So 12 plus 12 is 24. 24 plus 16 is going to give you 40, but that's going to be a minus. So we're going to take the -46 and subtract the 40. So that's going to give us -86. Did you guys get that? Hello? Did you guys plug it into your calculator? Do you remember how to find the determinant on the calculator?
Yeah.
Did you guys get that? Oh, Gabby gave me a thumbs up. Awesome. Okay, so guys, do you remember how I showed you how to do it before?
It was like you circle a number and then you cross out that line's number. And
Yes, that's called determinant by minors. Yes, yes, yes. And so if you guys remember that and you prefer, which method do you prefer? Do you prefer this or do you prefer the minors? The minors is what I gave you already. Do you prefer this method or the other one? Okay, wait a minute. Let me go in here. This one. Okay, all right. This is very straightforward. And then you know why I think I didn't tell you guys? It's because the textbook didn't mention it. And I completely forgot to show you guys how to do this one. Does that only work for 3 by 3? Yes, Josh. It only works for the 3 by 3. Yes. Either way will work, Paige. Okay. All right, guys. I'm like almost done. So let me finish this up. That was number 16. Oh, 17, we're going into the sequences now. You guys should be very familiar with the sequences. This one says the sequence is defined recursively. Write the first 4 terms. If A1 is equal to -2 and AN is equal to N minus A sub N minus 1. Are you guys going to be okay with this one? Hello. Do you guys need me to do it? We got to write the first 4 terms. Okay, first 4 terms. So they're giving you the first one, which is a -2. So they want you to find the second one. So A sub 2 will equal to 2 minus A sub 2 minus 1. Okay? So A sub 2 will equal to 2 minus the value of A sub 1. What's the value of A sub 1? It was -2. So 2 minus 2 gives you 0. All right, yes. So A sub 3, okay, we're going to go ahead and plug it in. So it's going to be 3 minus A sub 3 minus 1, okay? So this is going to be 3 minus A sub 2. A sub 2 is 0, so that's going to give us 3. And then the 4th term. You guys figure out the 4th term because I'm running out of room here. What's the 4th term, guys? What's the 4th term?
5.
5. You sure? Okay, let me see if I could squeeze it up here. So A sub 4 will equal to, okay, let's see here. N, which is 4. 4 minus A sub 4 minus 1. Okay, A sub 4.
Isn't your A1 a -2? So it's 2 minus -2, which makes it 4.
2
instead of 0.
2 minus, say it again.
Because your A1 is -2, so wouldn't it be 2 minus a negative A2, which changes
Paige,
it
why are you
to
always
add?
waiting until the last minute?
I was doing my work. I wasn't looking.
Oh, man. Oh, man. Okay, so that would be 4. So this one becomes 4. And so A3 minus, so this one will actually be a 4 as well. Okay, so 3 minus 4 would be 1.
-1.
Yes, -1. Okay, so right here you're gonna have A sub 3. So that'll be 4 minus a -1. So that's gonna give you +5. So yes, Lee, you were right. If I didn't leave out my negative there. Okay, 18, guys, is one of the summation notation, one of the sigma notation problems. It is to find the sum of this n is equal to 1 is the lower limit. The upper limit is 44, and the formula is 6n plus 6. And of course, you guys have this on your calculators. You can do it on your calculators. This is an arithmetic sequence. And when we are finding the sum of the terms in an arithmetic sequence, we use the formula n over 2 times a1 plus an. A1 is the first term, so the first term in the sequence will be 6 times 1 plus 6, which gives you 12. An in the sequence will be the last term, as in the 44th term. So you would do 6 times 44 plus 6. Oh, what's 6 times 44, guys? 240 plus 24, so that'll be 264 plus 12.
264.
Huh?
Never mind.
So 270 is the term? So I'm going to go into the formula. 44 divided by 2 times 12 plus 270. And then you're going to grab your calculator and plug this on your calculator. And obviously, if you already have the summation notation, you could just go ahead and plug in the entire thing into the calculator. Is that the final answer, Sarah?
It's 6,204.
Okay. Well, you know what? I'm just gonna go with you guys' answer. So I could expedite this 6,204. Okay. But if you don't have the graphing calculators, guys, you can actually go ahead and go through the process like this, and it should work. Hold on, you know what? I'm just want to make sure. Hold on a second, guys. Let me double check this. That was 264. 264 plus 6, 270. 270 plus 12, and then multiply it by 22. I'm just double checking. Yeah, it works. 6204. All right, everyone. Just a couple more. Oh, now we're into the ellipses, which we just finished covering. The next one is about the parabola, which we just worked on last class, so I'm not going over that one either. And then the last one, number 21, is on the hyperbola. So that's it, guys.